Exercise 1.4 Mathematics Class 9 R.D. Sharma. Define an irrational number. First question. Solution. A number is an irrational number if it has a non-terminating and non-repeating decimal representation. Question 2. Explain how irrational number is different from a rational number. Solution. On left side irrational numbers, on right side rational number. First point. A number for irrational number, a number which is not represented in the form of p by q. Rational number, a number which can be represented in the form of p by q, where q not equal to 0. Second point, for irrational number, it has non-terminating and non-repeating decimal representation. For rational number, second point is it has terminating, non-terminating and repeating decimal representation. Third point, example, root 2, root 3 pi, comma, 2.101001000, etc. Third point, for rational numbers, example 2 by 1, comma 2.14, comma 2.12 bar, comma 3.0121212 till infinity, etc. Third question, examine whether the following numbers are rational or irrational. First, root 7, it is irrational. Second, root 4, root 4 can be represented as 2 upon 1, which is 2, hence it is rational. Third, 2 plus root 3, it is irrational. Fourth, root 3 plus root 2, it is irrational. Fifth, root 3 plus root 5, it is irrational. Sixth, root 2 minus 2 complete whole square. Root 2 minus 2 complete whole square can be represented as root 2 square plus 2 whole square minus 2ab, which is 2 root 2 into 2. This is of the form a minus b complete whole square, which is a square plus b square minus 2ab, which comes out to be 2 square, root 2 square is 2, 2 square is 4, and minus this comes out to be minus 4 root 2, which is equal to 6 minus 4 root 2, hence irrational. Seventh, 2 minus root 2 into 2 plus root 2. Solution, 2 complete square minus root 2 complete square. A minus b, a plus b, it becomes a square minus b square, which is equal to 4 minus 2, which comes out to be 2, hence it is rational. Eighth question, root 2 plus root 3 whole square. Again, it is a plus b complete whole square. It can be written as a square plus b square plus 2ab, which is root 2 square plus root 3 square plus 2 into root 6. This comes out to be 2 plus 3 plus 2 root 6, which comes out to be 5 plus 2 root 6, hence it is irrational. Root 5 minus 2, it is irrational. Root 23, it is also irrational. Root 2 to 5, root 2 to 5 comes out to be 15 upon 1, which is 15, hence it is rational. 12th, 0.3796, 0.3796, if we divide by 10,000, it would be 3796 by 10,000. It can be represented as 0.3796 can be represented as 3796 upon 10,000, hence it is rational. 13th, 7.47848 goes till infinity. We can see 7.478478 is repeating again and again, hence it is rational. 14th, 1.1001001000 so on. It is also irrational. Fourth question. Identify the following as rational or irrational numbers given the decimal representation of rational numbers. Give the decimal representation of rational numbers. First question, root 4. Root 4 can be represented as 2 upon 1, so 2, which is rational number. Second, 3 upon root 18, it is also a rational number. Third, root 1.44. Root 1.44 is root 1.44 upon 100, which becomes 12 upon 10, so 1.2, which is a rational number. Fourth, root 9 upon root 27. Root 9 upon root 27 can be written as root 1 upon 3. It is a rational number. 3, 3 is a 9, 3 9 is a 27, 9 is a 9 or 9 3 is a 27. Hence, it comes out to be 1 root 1 upon 3, which is a rational number. Fifth, minus root 64. Minus root 64 can be represented as minus 8 by 1, which is minus 8, hence rational number. Sixth, root 100. Root 100 can be written as 10 upon 1, which is 10, hence rational number. Fifth question. In the following equation, find which variables x, y, z, etc. represent rational or irrational numbers. First, x square is 5. X square is 5, so x becomes root 5, hence it is a rational number. Second, y square is 9. Y square is 9, so y becomes root 9. Root 9 is 3 upon 1, which is 3. So y is equal to 3. Hence, it is a rational number. Third, z square is equal to 0.04. Z square is equal to 0.04. So z becomes root 0.04. Z is equal to 0.2, which can be written as 2 upon 10, which is 1 by 5. So z is 1 by 5. Fourth, u square is equal to 7 by 14. U square is equal to 7 by 14. So u becomes root 7 by 14. Root 17 by 14, sorry. U becomes root 17 by 14, which is root 17 upon 2. So u comes out to be root 17 by 2, which is a rational number. Fifth, v square is equal to 3. So v becomes root 3, hence a rational number. Sixth, w square is equal to 27. W square is equal to 27, so w becomes root 27, hence a rational number. Seventh, t square is equal to 0.4. So t becomes root 0.4. T becomes root 4 by 10, which is root 4 is equal to 2 and root 10 is root 10. So t is equal to 2 by root 10, hence a rational number. Sixth question. Give an example of each of two irrational numbers whose first point difference is a rational number. So the answer would be root 2 and root 2. Second point, difference is a irrational number. So for that example would be 4 root 3, 2 root 3. Third point, sum is a rational number. So example would be root 5 minus root 5. Fourth point, sum is an irrational number. Solution would be 2 root 5 and 3 root 5. Fifth point, product is a rational number. So solution would be root 8 and root 2. Sixth point, product is the irrational number. So example would be root 2 root 2. Seventh point, quotient is a rational number. So example would be root 8 comma root 2. Eighth point, question is a irrational number. That example would be root 2 and root 3. Seventh question, give two rational numbers lying between 0.232, 2332, 23332, so on, and 0.21, 211, 2111, 2 4 times 1, 2, so on. So we can see there is a pattern of 0.232 in first and 0.212. So they should lie between 0.232 and 0.212. Hence, two rational numbers between these two numbers would be 0.221 and 0.222. Eighth, give two rational numbers lying between 0.51, 511, 5111, 5 4 times 1, so on, and 5 0.535, 335, 335, 4 times 3 5, so on. So we can see first four digits 0.5 and 5, and for the second one 0.535. So the numbers should lie between 0.51 and 0.53. Required two rational numbers are 0.5152 and 0.532. Ninth, find one rational number between 0.2101 and 0.2222 that is equal to 0.2 bar. So the rational numbers lying between 0.2101 and 0.4 times 2 till infinity is 0.2201 double 0 1 triple 0 1 4 times 0, so on. 10th, find a rational number and also an irrational number lying between the numbers 0.303 double 03 triple 03 and so on, and 0.301 double 01 3 times 1, so on. So an irrational numbers lying between these two numbers is 0.3020 200 2 triple 0 2, and a rational number lying between these two numbers is 0.3011. Find 11th question, find two irrational numbers between 0.5 and 0.55. Solution, two irrational numbers between 0.5 and 0.55 are 0.510 100 1 triple 0 1 4 times 0 1, and 0.520 2 triple 2 double 0 2 triple 0 2 4 times 0 2. 12th, find two irrational numbers lying between 0.1 and 0.12. So two rational numbers lying between 0.1 and 0.12 are 0.10 100 1 triple 0 1, and 0.1101 double 0 1 triple 0 1 4 times 0 1, and so on. 13th question, prove that root 3 plus root 5 is an irrational number. Solution, let us assume that root 3 plus root 5 is a rational number. This implies root 3 plus root 5 is equal to p by q, because p and q are integers and q not equal to 0, and p and q have common factor equal to 1. Now since root 3 plus root 5 is equal to p by q, squaring both sides, we get root 3 plus root 5 whole square is equal to p by q whole square. This implies root a, we apply the formula of root a plus b whole square, so a square plus b square plus 2ab, that is root 3 square plus root 5 plus 2 root 3 into root 5, which is p square by q square, because of the formula a square plus b square as a square plus b square plus 2ab. This So this entire becomes 3 plus 5 plus root plus 2 root 15 is equal to p square by q square. This implies 8 plus 2 root 15 is equal to p square by q square, which becomes 2 root 15 is equal to p square by q square minus 8. So root 15 is equal to 1 by 2 p square plus p square upon q square minus 8. This implies root 15 is equal to p square by 2q square minus 8 by 2. Hence root 15 becomes p square by 2q square minus 4, 8 by 2, which comes out to be 4. So p square by 2q square minus 4 is a rational number. Therefore, root 15 is also a rational number, but we know that root 15 is an irrational number. New contradiction arises because of incorrect assumption that root 3 plus root 5 is a rational number. Therefore, root 3 plus root 5 is an irrational number. 14th question. Find three different irrational numbers between rational numbers 5 by 7 and 9 by 11. So 5 by 7 comes out to be 0.714285 bar, and 9 by 11 comes out to be 0.81 bar. Therefore, three rational numbers lying between them are 0.750, 7500, 75000, 7.754 times 0 till infinity, 0.7670, 76700, 76700, 7674 times 0 till infinity, and 0.80, 800, 8000, 84 times 0, 8 till infinity. Thank you.